Alrighty, welcome students. This is the practice exam for your IA3. Remember, it is worth 15% of your grade, and this is the last internal exam. Okay, so let's go through each question. We're going to start with the first few. The first question says, write the recurrence relation for an investment. Using A naught to represent the initial investment of 11,000 in a financial institution at 9% compounding annually. Okay, straight away you go to your formula sheet and it's talking about recurrence relation, the first thing I highlighted, and that's our yellow one here. So that's our recurrence relation, but we have to choose either this one for compound interest or this one for reducing balance loans. Okay, so that I feel like is the number one step, is you need to know which one you're using. So the one we have to use for this is the compound interest recurrence relation. Why are we not using the reducing balance loan? Because we don't have anything to do with capital R, which is your monthly repayments. Usually it's monthly, and we don't have that, and so we are just using our normal recurrence relation for compound interest. So question 2 will be where we use this reducing balance loan recurrence relation, but let's do it step by step. Okay, so we know the relation that we're going to be using. Recurrence relation is for compound interest, which is R A N. So pick this out for your formula sheet. That is the first step. From there we can calculate R. So we have to find R, and we know that's 1 plus I over 100 is compounding annually, so we don't need to worry about dividing the interest rate or anything like that. We just need to put the interest rate in, and so we've got 1 plus 9 over 100, and so that's 1.09. So I've got R. Now I will rewrite my equation. So I've got a n plus 1 is equal to 1.09 a n, and I need to say what my initial investment is. So a naught is equal to 11,000. And that's pretty much it. So this is our final answer with our recurrence relation and our initial amount. Okay, so that's with question 1. For question 2, let's read what the question says. Determine the loan balance after the fourth payment for the scenario. So Cody makes monthly repayments of that to pay off $30,000 motorcycle loan. It's compounding monthly. So we've got monthly repayments, compounding monthly. Interest rate is 3.5% per annum, which means per year. So I need to convert that interest rate to monthly. Interest is added before the payment is made at the end of the month. So firstly, I need to use the correct formula, and so in this case I am using that one there, because it is a reducing balance loan of a motorcycle with repayments being made every month. Okay, so I need to make sure my R is converted to monthly, the interest rate in R, and my capital R is my monthly repayments. That's already given. Okay, so I'll go back and I will write my recurrence relation. So it's the same compound interest one, but we're subtracting monthly repayments of 400. Okay, so again I need to find R first. 1 plus I write over T over 100, so that you can remember that T is the compounding periods, which is monthly, so that T will be equal to 12. Okay, I have got R is equal to 1 plus 3.5 over 12 over 100. So divide by 12, divide by 100, and I should get R to be equal to 1.002916667. Now whenever you're given this and you need to find the balance after 4 payments, or sometimes even how many payments it takes for the loan to be finished, use the full value of R. Okay, and you can just leave this in your calculator and it will do the work for you. So the question is, I need to know the loan balance after the fourth payment. So I'll rewrite my recurrence relation with my R that I've just calculated. AN minus capital R, which is 400. That's my monthly repayments. It's in the question. So I've got this. And I'll always say my initial amount, which is 30,000. Yes. Okay. Now from here, I need to find A1, A2, A3, and A4, which represent the amount after every month of payment. So I will have A1 will be 1.0029166667 times the initial amount, which was 30,000. So that's A0 and A0 minus 400, and that you get 29,687.5. So that's after the first month. That's the balance left. So 30,000 was the price of the motorbike. After interest that was added and the monthly repayments taken off, the price has dropped a bit. His total amount has dropped a bit. So in the second month, we're going to use the same interest, but this time instead of 30,000, we have a new value of A1 that we're going to put there, minus 400, and that is 29,374.1. A3, again I'll write the interest rate, and then the new value, which I just calculated, minus 400 is 29,059.8. Then A4, the last one, and that will give me 28,744.5. Questions does not say whether it's leave it to 2 decimal places or 1, but to 2 decimal places this is 5.2. So if it doesn't say, always by default leave it 2 decimal places, and then we can write our final answer as loan balance after 4 payment is $28,744.52. That's my final answer. Okay, we are going to do question 3 as well. So question C3 says calculate monthly repayments for Maddie, who needs to borrow $600 to purchase a couch. His yearly interest rate is that, compounded monthly. The loans to be paid back in 3 years. Again, jump to your formula sheet. This one, some students will confuse it for this because it talks about monthly repayments that you have to calculate, right? But actually the formula that we need is simply the compound interest formula on the top right there, which is highlighted in green. So we just need this one. All right, once we've got the total amount, we can divide it by how many months there are in 3 years to get our answer of monthly repayments. What will be the monthly repayments? So we'll jump here, write our formula, compound interest formula. Amount is the principal, 1 plus I over T, which is the compounding periods, to the power of n times t. So in the formula that we have in the formula sheet, the t is not there, but I write it just so that I know that it's compounding monthly, so t should be equal to 12. So the total amount is the 600 into 1 plus 3.75 on 12, that whole thing divided by 100, to the power of 3 years times 12. that into my calculator. Make sure you're very careful when you're working these things out. You should get 671.33. Just round decimal places. And so, okay, the monthly payments, what it's asking for, would be $671.33 divided by 36. Now, why 36? Because in 3 years multiplied by 12 months, we get 36 months. Okay, so this is the reason why we'll divide by 36, and our final answer will be equal to $18.65 per month. That is our final answer.